Hi, Yanon, and welcome to Wednesday's science lesson. Today we're learning about the greenhouse gases and the greenhouse effect. So we're looking at greenhouse gases and greenhouse effect. You've touched on this in Key Stage 3. I imagine you also probably touched on this in Key Stage 2 as well, in Year 7A and probably in primary school. So this shouldn't be too new for you, but we're going to go into a lot more detail today about how the greenhouse effect works, what the greenhouse gases are, how the greenhouse gases are being produced, and what is kind of currently happening in the world today. To start with, though, I'd love for you, please, to answer these 6 starter questions for me, please. So pause the video now and answer these starter questions. So I hope you answered those questions. We'll just go through the answers. There's plenty of ways in which to reduce global warming. I've just listed a few here: less deforestation and more tree planting, reduce the burning of fossil fuels, using more sustainable energy resources, recycling more. The list kind of goes on. So you might have had them, you might have had some other ones. All right, basically any way in which we can produce kind of less carbon dioxide or fossil fuel, burn less fossil fuels, or ways in which we can kind of take carbon dioxide out of the air by planting more trees, or by recycling more, because as we've talked about previously, if you recycle more, you use far less energy recycling than you do creating a new product, which is really good there. 2 types of pollution caused by humans. Well, there's 3 main types, which is air pollution, water pollution, and land pollution. The 3 main types. Just need to name 2 of those. Chemical composition of shells is actually calcium carbonate, so CaCO3. That should be a little 3. What gases are released by volcanic activity? So 3 types of gas are the main ones, which is ammonia, water vapor, and carbon dioxide, which is why our early atmosphere was filled with those 3 gases, because they're the 3 gases produced by volcanic activity. What was the effect on the Earth of the decrease in carbon dioxide? So global cooling. So you actually cooled the Earth down from what it originally was. You also formed more oxygen, which formed the ability for plants and animals to grow on the surface of the Earth as well. And then what are the 2 ways cells divide? Mitosis and meiosis are the 2 ways that cells divide. So give yourself a score out of 6 for that. If we talk about Earth's early atmosphere, so we've talked about this on Monday. So it was mostly carbon dioxide with water vapor, and then there was nitrogen, ammonia, methane. And then the temperature was 400 degrees Celsius plus. So it was really, really high. And then, as we talked about, the development of oxygen and reduction of carbon dioxide, the Earth's surface has cooled to around 20 degrees Celsius, give or take. Okay, it's just the average temperature of the Earth, with 78% nitrogen, 21% oxygen. So as you can see there, obviously, by reducing the carbon dioxide amount, we have cooled the Earth down. So reducing carbon dioxide cools the Earth. So these are some questions I want you to be able to fill in during this lesson. So what I would like you to do is pause the video and write these 6 questions down. And then hopefully by the end of the lesson, you should be able to answer these 6 questions. So what is the definition of global warming and the greenhouse effect? What are the 3 main greenhouse gases and where do they come from? What are the likely effects of global warming? What would happen if there was no greenhouse effect? Why is the concentration of methane increasing around the world? And then what can we do to try and reduce or slow global warming? So pause the video now, please. Write down those 6 questions, and then hopefully by the end of the lesson, you should have been able to answer those. So just a global warming kind of a recap. So global warming is the gradual increase in overall temperature of the Earth's atmosphere. So it's generally attributed to the greenhouse effect caused by increasing levels of carbon dioxide and other pollutants. So the global warming is the average temperature of the Earth is increasing. So if you were to take an average temperature from all over the world for 1 year, that temperature is increasing as we go along. So that is what global warming is. All right, and then as you see the two pictures here, these are the greenhouse effects. These pictures aren't global warming, they are the greenhouse effect. Right? It's a bit hard to take a picture of global warming. The only picture that really kind of sums it up is there is a video of the Earth's temperature used in colors, and as you can see over the time, it gets hotter and hotter and hotter until pretty much the whole world is just covered in red because it is far warmer than what it was. So, going over the greenhouse effect, lovely there. A little snowman outside, it's cold, but yet my greenhouse is lovely and sunny and warm, and my plants are growing. So the greenhouse effect is the natural process by which the atmosphere traps some of the sun's energy, warming the earth enough to support life. So that's really important here. The greenhouse effect has been around before humans and will probably be around after we go. Okay, it's not a new phenomenon. It's been happening for hundreds, if not hundreds of thousands, if not millions of years. Okay, in fact, it has been happening for hundreds of millions of years. So it is a process that has been going on for a long time. And that's really important. To answer one of your questions earlier, like, why is it important that we actually do have the greenhouse effect? And basically, without the greenhouse effect, the Earth would be minus 16 degrees Celsius, which is not livable or habitable for humans. So the greenhouse effect is being magnified by human activity. So it's not created by human activity, but we are making it worse. So here we have sun's rays, they come in and then they're hitting the earth and then reflecting back off, and then some energy is reflected and transferred into space. Some energy is absorbed by the greenhouse gases in the atmosphere and radiated back to Earth. So this is a really important diagram here. So some of the energy is being radiated back to the Earth, some energy is escaping back into space. This is a really important diagram, so I would suggest you draw it for me, please. So pause the video and draw this diagram. It's really important that you know what the greenhouse effect looks like and the fact that not all radiation is absorbed. Okay, not all radiation is absorbed, but enough is absorbed that the Earth is warmed, and then because we're releasing more greenhouse gases, this effect is being magnified by humans. Okay, so hopefully you managed to draw that. On we go. So the two main gases are carbon dioxide and methane. But you also got water vapor in there in some of the other gases, and then nitrous oxide, fluorinated gases, and then other gases. The two main ones, carbon dioxide and methane. So, global warming. Greenhouse effect is necessary to keep us and to keep the Earth warm enough to sustain life. So without the greenhouse effect, we wouldn't have life on Earth. However, we're increasing those levels of carbon dioxide and methane, which is increasing the greenhouse effect, which is then therefore leading to the change in temperature and global warming. So only a change of a few degrees could lead to big changes in our lives. So this is then leading to melting ice caps, which is therefore causing the sea levels to rise, water to get warmer, which means that water will hold less carbon dioxide. Because remember, on Monday's lesson, we talked about the fact that water and the oceans hold quite a lot of carbon dioxide. But if you get that warmer, they hold less carbon dioxide, which reduces the carbon sink size and magnifies the problem more. And then as the Earth warms, the ice caps will melt, releasing stored methane, magnifying the problem even more. And this is creating a positive feedback loop of ever-increasing temperature. So this is a positive feedback loop. So basically, Earth gets hotter, which then Arctic sea ice melts, and then instead of ice refracting or reflecting sun's rays, the seawater absorbs more light, which means the Earth gets hotter again, which means more Arctic sea ice melts, which means more water absorbs more energy, which means the Earth gets hotter, and so on. It's a spiraling problem. And then the other spiraling problem is that thawing tundra, and then so that's tundra, which traps lots of methane and carbon dioxide, is starting to thaw and melt, which releases that carbon dioxide and the methane. And then heat stresses forests, it damages forests, which reduces their ability to absorb carbon dioxide. And then methane also hydrates in that, and then you get these oceans that warm, which then release CO2 and methane, which means the Earth gets hotter, which then this means the cycle gets even worse and even worse. And then to make it even worse, humans are releasing more CO2, much, much, much more CO2, which means the Earth is getting hotter again, and so it's spiraling and spiraling and spiraling, which is a massive, massive, massive problem, which is why we're talking about it and why you're learning about it and why it's going to be one of the most significant problems in your lives, is to do with global warming and climate change, which is why you need to learn about how important it is to be saving the planet. So, possible effects of global warming: rising sea levels, loss of low-lying land. So there are literally some countries that within the next 100 years will not exist. Tuvalu and the Maldives are two island countries where their average sea level is below 2 meters. So within 100 years, they might lose most of their islands. Their whole islands, all of their land is gone. They're having to plan for in 100 years, probably in your lifetime, they won't exist. They'll have to literally move their whole country because they're going to lose it. They're not the ones that have created this problem, but they are the ones that are going to suffer because of it. We're just going to lose lots of habitat, lots of plants and animals dying, loss of biodiversity, organism distribution changes. Some animals may favor it and spread, while others will die off. So you get this great disparagement between animals that do really well in hotter temperature and animals that don't do well in hotter temperature. It's going to change the migration patterns of animals. Some also believe that we'll see a rise in severe and unpredictable weather events, which we seem to be seeing, and there seems to be quite a lot of evidence currently that this is being caused by climate change and global warming. So more storms, more hurricanes, more flooding, more droughts. So this is called the domino effect. So if one gets worse, then another gets worse, and another gets worse, until eventually it is just unbearable and horrific. So I have two questions for you here that I would like you to do. Question one: what would happen if there was no greenhouse effect? And then number two: why is the concentration of methane increasing around the world? So have a look back at your notes or this slideshow, and you should have the answers to these two questions. So pause the video now and answer these two questions. Okay, we'll go through the answer. So without the greenhouse effect, Earth would be very cold with little or no life. So it would be about negative 16 degrees Celsius. So we wouldn't be able to sustain life, and therefore there would be very little to no life on the surface of the Earth. There might be some life under the oceans, but not on the surface of the Earth. And then why is the concentration of methane increasing around the world? So remember we talked about in that cycle, you have permafrost melting. So these ice caps and permafrost actually have trapped methane in them. And so when they melt, they actually release methane. Methane is 30 times more potent at heat trapping than carbon dioxide. So it is incredibly, incredibly bad, this melting permafrost. So if you were to look at this, this is a graph of global temperatures. And if you look at it, you would say, oh, it's not too bad. Look, from 1998 to 2008, the average has actually gone down. 2008 was colder than 1998. However, that's just one tiny little bit of a graph that from 1960s to 2010 shows what is actually happening, which is the fact that it is going up. The average has gone up over a degree in the last 50 years, and that's only to 2010. It's much higher now. And then the other graph here shows from 1965 to 2010 what's happening to carbon dioxide emissions. So a type of question in an exam would be, analyze this data, what do you conclude? So what can you see from this data? So from 1965 up to this is 2010 under here. What's happening to carbon dioxide levels? So this is carbon dioxide in the atmosphere. And then this is global temperature. So as the temperature rises from 1960 to 2010, what is happening? So if you were to analyze this data, you compare both and say, 1965, carbon dioxide was at about 12 billion tons of metric tons of carbon dioxide emitted, and the average temperature was around 57 degrees Celsius. However, in 2010, the CO2 emissions are 34 billion metric tons of carbon dioxide, and the global surface temperature is now 58 degrees Celsius. Fahrenheit, sorry, this is an American. Then say the average trend is that as carbon emissions are rising, global temperature on average is rising as well. Okay, so you're analyzing it, you're using specific data in order to draw conclusions, and you're comparing and contrasting both of these and saying, on average, CO2 is rising and the temperature is rising, because that's what was happening. So the amount of carbon dioxide in the Earth's atmosphere has risen in the past, largely due to the amount of fossil fuels now burned. Okay, so carbon dioxide is rising because we are burning lots of fossil fuels. Right, electricity in your house, the petrol that powers a car, right, all of these are burning fossil fuels to get these for us. It's difficult to predict with complete certainty the effects of climate of rising levels of greenhouse gases. However, most evidence, most peer-reviewed, so peer-reviewed means that a scientist has written an article or a paper using evidence, okay, peer-reviewed, so they've used evidence, and then other scientists have looked at the evidence, have looked at that conclusion, and have agreed and said that this article that they've written and this piece of information is correct. So that's what peer-reviewed means. Okay, so sometimes you get questions in your exams which talk about the difference between peer-reviewed and just an article online. So peer-reviewed means that multiple scientists have looked at the article and have all come to the same conclusion, or have said that the conclusions drawn in that article or that scientific paper are correct. Okay, so the vast majority of peer-reviewed evidence agrees that increasing the proportions of greenhouse gases from human activities will increase the average global temperatures. And as you can see here, what we actually can see is we can actually see the carbon dioxide levels in the atmosphere from 800,000 years ago. So what they do is they drill big giant ice cores into in the Arctic and Antarctic, and then within that ice is trapped gas, because obviously when permafrost melts, that ice melts, it releases the gases. It's because they're trapped gases in that ice. So we can actually drill really, really, really deep down and look at the levels of carbon dioxide in the atmosphere. And as you can see, carbon dioxide varies. Okay, we've got points in here where carbon dioxide levels peak. So it is a natural cycle of carbon dioxide going up and then down and then up and then down and then up and then down and then up and then down. It is a natural cycle. However, look at what the line is doing now. Okay, it's here 409.8 parts per million compared to the previous highest, which was 300 parts per million.
look at the steepness of this line. Okay, it's because these things happen over thousands of hundreds, if not thousands of years. Okay, that there between there and there, or between there and there, that's hundreds of thousands of years. All right, that's at least 10,000 years difference. While here, we've got the line which is pretty much vertical because of the amount of carbon dioxide we're releasing into the atmosphere. Okay, it's unsustainable, and it's raising it at such a level that it's pretty much vertical. All right, and this needs to change. This is the problem. It's the vicious cycle of releasing more carbon dioxide means the Earth gets warmer, which means it melts more ice, which releases even more carbon dioxide. Okay, we're at a climate emergency. So, your task here for the end of the lesson, till the end of the lesson, explain what we can do to try and reduce or slow down global warming. So try and use these keywords: emissions, deforestation, recycling, renewable energy, fossil fuels planting, less aerosols, laws. If you're struggling with it, look online, search online, find out what can we do to slow down global warming. Okay? This is probably one of the most serious topics we'll talk about during your schooling. It's incredibly important, and it's going to be one of the biggest issues in your lives. So I hope you've enjoyed the lesson. Make sure you finish this task, please, for the rest of the lesson up until the bell or the lesson finishes. And as always, have fun, take care, and I will talk to you on Friday. Oh, and watch these YouTube videos for some extra information.